So here we have to derive all the three equations of motion using graphical method. That means we have to actually first of all have a graph with us. Now first thing that we need to keep in mind is that here the motion of the object is in uniform acceleration and the object is moving in a straight line. So here you see we have two values of time and two values of velocity. That means we have to make a velocity time graph. That means on the x-axis we will have time as it is an independent variable, and on the y-axis we have velocity as it is a dependent variable. Now we know we have time as 0 and t. So we have 0 already over here, so we'll write t over here and we'll write u and v, that is initial velocity and final velocity. Now we know that when time is 0, velocity is u. That means the first point will come over here. Now secondly, time is t and velocity is v. So time is t and velocity is v. So this is the required second point. Now we join these 2 points. After joining these 2 points, there is another construction that we have to do. We have to draw a straight line from u till this particular segment. Now we name them. We name everything. You can give any sort of name to it. We have given it as A, B, C, D, O and E. Remember, this is A, B, C, D and this is O and this is E, right? So here if you see properly, this distance is nothing but u. So if this is u, this also becomes u. Similarly, if this is t, this also becomes t. This entire distance is v, so this entire distance also becomes v. Now let's pay attention over here. If this entire distance is v, this distance is u, that means this distance becomes v minus u, and this distance also becomes v minus u, right? So both these distances are v minus u. So this is the graph that we have. So using this graph, what we will do is we'll derive all the three equations of motion. Let us now derive the first equation of motion. We know that initial velocity is denoted by u, final velocity is v, and v minus u is nothing but change in velocity. Let's write down first. Initial velocity is denoted by u, but we know that u over here we have OD as u. So we write u is equal to OD, equation number 1. This is from the graph. Final velocity we know is v, and here you see it is nothing but OC. So we have v is equal to OC, which is also equal to BE, because OC and BE is nothing but the same. This is equation number 2. Now we know that time is t and this time in this case is OE. So we have OE as the time. This is equation number 3. Now we know that the formula for acceleration is change in velocity upon time. So we have acceleration is equal to change in velocity upon time. Now what is change in velocity? It is final velocity minus initial velocity upon time. Final velocity from the graph, we know that it is v, final velocity is v. So we have two values of v, we have OC and we have BE. So what we'll do is we'll write OC. Initial velocity is OD, that is u, OD, you see here? So it is OC minus OD upon time remains t. Now what is OC minus OD? OC minus OD is nothing but CD, right? That means we have CD upon t. Now here we have A, that is acceleration. So we have A is equal to CD upon t. So if we shift t over here, we get AT. That means CD is equal to AT, right? So this is equation 1. Now this CD is nothing but AT, so we'll shift this AT over here and we'll remember that this is nothing but this AB distance is AT or BA is AT. Now one thing we know from the graph is that BE is equal to AB plus AE. Where is BE? BE is equal to AB plus AE. But what is the value of AB? It is AT. And the value of AE is nothing but u, right? That means we'll substitute the values and write it as V is equal to AT plus u. Now if V is equal to AT plus u, we know that V will be equal to u plus AT. That means here if you see we have V is equal to u plus AT, and this is nothing but the first equation of motion. So after understanding the first equation of motion, let us now derive second equation of motion. Now we know that second equation of motion is nothing but S is equal to ut plus half at square, and S is nothing but the distance. That means if from the velocity time graph we wish to obtain the distance, that means we have to find the area under the graph. And area under the graph is nothing but this quadrilateral, that is DOEB. That means the distance travelled will be equal to area of quadrilateral DOEB. But if you see properly, area of quadrilateral DOEB is a combination of two figures, that is a rectangle and a triangle. That means S will be equal to area of rectangle DOEA plus area of triangle DAB. So this is the rectangle and the triangle at the top. Now we know that this is length into breadth. Now length into breadth. So we have two lengths and two breadths. You can take any one of them. So here what we'll do is we'll write S will be equal to AE into OE. So where is AE? AE, and OE is over here, right? So this is area of a rectangle. Now here we have half into base into height, or we can say half into height into base. So we are writing AB into DA. So AB is the height and DA is the base, right? Now what we have to understand over here is that we have certain values of these terms, right? So let us write down the values. We know that AE is equal to U, right? Where is AE? AE is over there. Here there is AE. So AE is nothing but U, right? Now OE is equal to T. OE is equal to T. And one more thing we know is that OE is equal to DA, which is equal to T. And one more thing, AB or BA, if you see, is nothing but AT, right? Because CD is equal to AT. Now we will substitute these values in the above equation. So we have S is equal to AE into OE. AE is nothing but U and OE is nothing but T. So we have U into T. Plus half remains half. AB. Where is AB? AB. AB is AT. So we have AT, and DA is nothing but T. So here if you see, we have AT into T, which becomes AT square, and U into T becomes UT. So we have S is equal to UT plus half AT square. So this is nothing but the second equation of motion. Now that we have derived both the equations of motion, let us move on to the third equation of motion. And again, third equation of motion is V square is equal to U square plus 2AS. That means we have S, and S is nothing but the distance travelled. So again, from the velocity time graph, we have to find the area under the graph to find out the distance travelled. And again, we know that this entire shape is nothing but a trapezium. That means S will be equal to area of trapezium, that is ODBE. We have just slightly changed the name. The formula is half into sum of parallel sides into height, right? So formula is half into sum of parallel sides into height. So S is equal to half. So we'll write half as it is. Sum of parallel sides. We have two parallel sides over here, right? We have this side, which is nothing but OD, and we have BE. So OD plus BE into height is nothing but this thing, that is OE, right? So now we know that the value of OD is equal to U. The value of BE, where is BE? There is BE, is nothing but V. And we have OE, which is nothing but T. So we have OE is equal to T. So we'll substitute the values. We'll get half into OD plus BE, that is U plus V. So we get U plus V into OE, and OE is nothing but T. But in the third equation of motion, we know that it is V square is equal to U square plus 2AS. And we don't have time. That means we have to replace time. So we will use the formula of acceleration. We know that acceleration is nothing but change in velocity upon time. So A is equal to V minus U upon T. So T will be equal to V minus U upon A. We'll just shift it. Now we have the value of T, that is V minus U upon A. We'll substitute this value in this equation. So we'll write all these things as it is, and we'll substitute T by V minus U upon A. So let's write this. So now what we are doing is we are writing half as it is, U plus V as it is. So here instead of T, we will substitute the value V minus U upon A. So we have V minus U upon A. So V plus U into V minus U remains as it is in the numerator, and in the denominator we have 2 into A, that is 2A. Now we'll shift 2A into the numerator, so we get 2AS. So what we'll have is we have 2AS is equal to V plus U into V minus U. Now V plus U into V minus U becomes V square minus U square, because A plus B into A minus B becomes A square minus B square. Now we'll shift this u square on the left hand side, so we get u square plus 2as. What remains is v square. So the answer that we obtain is v square is equal to u square plus 2as, which is actually the third equation of motion. So these were the three equations of motion.